Now I have done all the addition. I have taken reading. See, this was 40. This till 40 tube. This is part of your graph plotting thing. Okay. Now for sample 1 my reading is 0.701. I have kept sample 2 in spectrophotometer. So reading for that is, click on read unknown. Reading for that is 0.106. Okay.
So we are done with the experiment. So here you can see 1 ml of standard sulphate solution is equal to 0.1 mg of sulphate ions in 100 ml. So okay, for this you go through your procedure and then you will come to know that how have we arrived at this. Okay. So what does that mean? That means there are 0.1 mg of sulphate ions in 100 ml of solution. Okay. So what does that mean? If you are converting this ml into liter, that means that 1 ml of standard sulphate solution contains 1 mg per liter of sulphate ions. So we have calculated for each standard solution concentration. Okay, so for 5 ml of standard sulphate solution, you will be having 5 mg per liter of sulphate ions. Okay, so likewise we have calculated for all the concentrations 5, 10, 15, 20, 25, 30 and 40 respectively. And these are the values of absorbances that we have taken from spectrophotometer at 420 nanometer, right? So what do we need to do? That, see, here we know the sulphate ion concentration in the standard solution. Okay, like those standard concentrations. So what we have done here, we have first plotted a graph for this 5 ml concentration. We have plotted this value that we have got from spectrophotometer. Likewise we have plotted a graph, and you need to take any 3 points passing from the origin. Okay, so that is best fitted curve you need to go for. You can take any points, but that graph should be passed through the origin. Okay, so we have taken this 3 points, like including origin 4 points we have taken, and we have plotted the graph and extended it. Okay, now that becomes our standard graph. Okay, like all the known concentrations with known absorbances we have drawn on a graph. Now sample 1's absorbance was this much and sample 2's absorbance was this much. So we were aware about the sulphate ion concentrations of that standard solutions, right? But we are not aware about the sulphate ion concentration of sample 1 and sample 2. So what we have done in this standard graph only, we have gone for the absorbance value of, see, y-axis pe absorbance or optical density, and on x-axis we have sulphate concentration. Okay, in mg per liter. So for this value of optical density or absorbance, like for sample 1 we got 0.701. Okay, so we have plotted this on this graph, and we need to just drop one vertical intercept on this x-axis so that you will get this value. So by using standard graph, we have calculated the value of unknown water sample. Similarly, we have calculated for sample 2. Sample 2's absorbance was 0.106. So what we have done, again on standard graph, we took that value 0.106 and we just dropped one vertical line to get its sulphate ion concentration. So to summarize, what we have done, we have first plotted a standard graph like by using standard concentration of sulfate ions graph, and we have measured the sulfate ion concentration of unknown water sample. Okay, so one more homework for you. You need to check for the acceptable and permissible limits of all the parameters that we have studied in IS 10500/2012. Okay, and as an environmental engineer, you should be aware of each and every parameter given in that IS code. So okay, this was all about this sulfate and estimation in given water sample. For any doubt or query, you can ask Latkar ma'am. Okay, bye bye. Thank you.